Hello, my name is Ethan Dahmus and this is my video submission for Lab 9. Have you ever had the problem of having a coffee that was too hot to drink and burned your mouth? Well, this device will solve that problem perfectly by ensuring that your drink is always at the perfect temperature. All you got to do is insert this arm into your drink, which has a temperature sensor that will read the temperature. Then you got to set what temperature you want. For this, we'll do 80. And as you can see, once the measured temperature is above the desired temperature, the fan will start to blow to cool down your drink. For this demonstration, I'm going to pull it out of the water so that it's a little bit quicker. And once it gets cool enough, it plays a chime and alerts you that your drink is ready. For the wiring of this system, it was pretty simple. I ordered a temperature sensor online that uses one-wire communication to send information to a digital pin to accurately give temperature readings. Over here, I've got a DC motor that is powered by one of the NPN transistors available in our pack. And it's powered by this external power supply and digital input pin for controls, whether or not the motor is on or off. Diving into the code a little bit, for the Arduino, there were libraries available for the temperature, which was really useful. But basically, I just initialized some stuff with that. Initialized some more stuff here with the pin modes of the motor pins and stuff like that. This paragraph right here is about parsing information that it receives through serial communication with the processing. And then right here, we have some built-in functions for the temperature libraries that will give me the temperature in Fahrenheit. And so then I put those into a string to send to processing for serial parsing, and then do a quick logic check where if the temperature of the sensor is greater than the temperature that is desired, it will turn on the motor, and if not, it will turn off. Moving on to the processing, I imported the serial and sound libraries for use. And initialize a bunch of variables and objects here in the start. In my setup, I begin serial communication and make some objects for a sound library, and then I do the serial parsing from the Arduino. Next, I have a little bit of logic that ensures that there's no false positives by checking that there are at least 5 temperature readings that are low enough before declaring that the drink is ready, which is achieved through just changing this Boolean variable. Next, I have a little bit of text for parsing back to the Arduino, and I map the Y temperatures and the desired temperatures from Fahrenheit into coordinates on my screen. So it's going from the minimum temperature to the maximum temperature and from the bottom and top of the screen. Next, I'm drawing those temperatures on my graph in a similar way that we did in the oscilloscope processing. And then at the end, I have my X, which is the time domain. It's just going up by 2 every cycle, but it also checks and makes sure that it's not going off the screen. And if it does, it just resets X back to 0. Here, I'm calling some functions like drawing the legend and also checking if the drink is ready, and then making the screen for the drink. So in my draw axes, I basically just had the y-axis, x-axis, and then I made little ticks and temperature labels for those on both the y and the x, and also had the axis labels. For my legend, that was the thing that was at the top of the screen. I basically just had a little dot showing the color of the different temperature values and also labeling them. Here was where I take the user input. This was something I actually had to look up online and find a tutorial for because I really had no idea what to do, but it actually ended up not being too hard. And then at the end, we have drawing that the drink is ready, where it basically just fills up the screen with green, says it's ready, and then utilizes the sound library here to play 4 or 5 different notes in a sequence that make a little chime. And that's about it. Also, here's showing that I have my numbers on my 3D print. There.